Hi, my name is Christian Jackson Robinson. This is my contribution to our robot project. I first started the project by making the MIT App Inventor code, which is just basic code that just allows forward, backwards, turn left, turn right. It's nothing too important. It also is able to connect to the Bluetooth of an Arduino Nano that is sent out the signal. I also had to code the Arduino Nano to achieve that as well, which was done. I'll talk about it in the previous slide. But anyways, I used MIT App Inventor 2 to do this, which also required some research as well because I didn't know how to use it that well. But I found that the research was fairly simple to replicate, so I didn't have to do. I'm not gonna say I didn't do much, but it wasn't that hard to do. Also, on here, I also made another. Next slide. I'll talk about the next slide. Here it goes. This is a different app that I was just using to experiment with the servos that we were given. This app would have been able to connect to the Nano as well, while also being able to control the servos with certain, as you can see on here, with button pushes like the 45, 90, 135, 180. They would have went to those degrees if you pressed it. And then there's the slider as well, which you can also decide the angle of the servos. This is the coding blocks that you also have to do with MIT App Inventor, because you can't just make the background of the app, like the first page. You have to do the coding as well. The coding basically is the build-up of it. Like you first have your button press. Hold on, let me go back to the previous slide. You'll be able to tell better. Like, hold on. Say I press the forward button, you will be able to see. My bad, that's the wrong slide. Say you press the 0 button, then it will correlate with the Arduino Nano app code, and it will be able to tell the servos to go to that certain angle because that's how I depicted it in the Arduino Nano. And that's basically the whole point of the coding, is to connect to your Nano as well. Well, not as well. It actually connects to your Nano. Connected and all that. There's even a function that that can tell you if your app is connected to your Nano, as well as there's the slider function as well. It's all on there, as you can see. Like that's the building. Surprisingly, that's just the building blocks of it all. This, also when I first started, I was working with the Arduino Nano as well. I was testing that, bits and pieces of that. I used a light blue app. Well, this is the part I was talking about where I get to it later. There's an onboard LED light on the Arduino Nano that you can see as you can see it blinking on and off. What I did, I created a code that first it will send out the Arduino Nano signal, Bluetooth signal. It will control the LED app if you put in a certain number value. Say you put in 0, it will blink slow. Put in 1, it'll start blinking faster. You put in 2, it'll blink. That's when it'll blink the fastest. Only from 0 to 1 to 2. This is the app that you'll be able to see it on. Like say you send out the signal, you'll see Arduino on there. And that'll be the signal that you connected to. We also created, using Tinkercad, we also created a similar schematic that just shows off our starting at first. Because at first we just created basic like delay and simultaneous using code that will make the servos go on the sweep from 0 to 180 and back and forth. We managed to choose that so it'll either go one at a time or simultaneous. This is just how it'll look in Tinkercad. As you can see, the servos that are connected to each of the pins and the power sources that are connected as well. It's just a better view of it. This is the in-depth of the code that I created. More adjusted so we could achieve the test that we wanted. it is using simultaneous movement, which is basically, first you have to assign the servos, attach them to a certain pin, and then each void loop, you will tell it to go from 0 to 180 in +1 increments. By having them all in there at once, they'll all do that simultaneous. Then you have the delay function, which tells them to wait the 15 milliseconds. Then you have to go backwards from 180 to 0 in -1 increments, all at the same time. And we just do that over and over and over and over again until basically you unplug it, because you cannot stop it yourself. I had also helped with zeroing the motors, which is, there was 2 zeros we had to do. We had to find the 0, and we also had to find at what angle would be appropriate to attach the horns to it as well. Which we messed that up so we had to do that a couple of times, but it wasn't that hard. We used the sweep function as well to attach it to it, so we'll be able to see where 90 degrees on the servos was, and that's how we would attach it to that horn. Because if you don't do it that way, the robot would kind of turn in on itself and wouldn't be able to achieve what we wanted to do. Like say we wanted to be on these X and Y axis, and without doing it that way, the robot would just mess up. This is, I didn't make this personally, but I helped adjust it somewhat. This is the frame-by-frame code that we eventually decided to use, because it just seems more simpler than the array code, which was to just use have the servos read all the angles at once in order. But we didn't feel that the servos could achieve this in such rapid speed, because we feel it'll overload them. So someone in our group decided to use the frame-by-frame way, which is just a delay in between. I helped with this one by changing the values so they were equal to each other. So, because before it would just do like a bunny hop. Now, when you changed it so that they'll be equal with each other, it actually achieves some walking. This is just a picture of me with the code debugging and all that. It's talking about stuff like the servos and all that. There's nothing too much in it. We just talk about how the adjustments were made. My attempt at making the robot walk backwards, which I haven't figured out. I believe it had something to do with the placement of the values, but time increments didn't allow me to figure that out eventually. My bad. Research. We had researched what was the proper way of wiring the Arduino Nano with the motor driver, and that's why I put it on there, because I don't have a coding background, so I spent most of the time looking up just how this should be done, and that's a fairly accurate way of doing it. I also do research. That's how I found the schematics for it all too, and then that's it.